Welcome back to our Spring Boot tutorial series. In today's video, we will dive into the essential HTTP methods, how they correspond to CRUD operations, and the importance of MIME types in HTTP requests and responses. Let's break them down one by one. So, the most common use of REST is over HTTP. We can actually leverage the HTTP methods for CRUD operations. In RESTful web services, the HTTP methods, also known as verbs, correspond to the CRUD operations. CRUD stands for create, read, update, and delete, which are the basic operations performed on data. Here's how each HTTP method maps to these operations. Post is used to create a new resource. When you send a post request to a RESTful web service, you're essentially asking it to add a new resource to its collection. Post is not idempotent. Multiple identical post requests will create multiple resources with the same data, resulting in duplication. Get is used to read or retrieve a resource. When you send a GET request, you're requesting data from the server. GET requests should only retrieve data and should not cause any side effects on the server. GET is idempotent. If you hit multiple GET requests, they will produce the same result without any side effects. Put is used to update an existing resource. A put request typically requires the entire resource data and updates the resource with the given data. Put is also idempotent. Multiple identical put requests will result in the same state of the resource as making a single request. Delete is used to delete a resource. When you send a delete request, you're asking the server to remove the resource. Delete is idempotent. Multiple identical delete requests for the same resource will result in the resource being deleted and no further side effects. Next, let's dive into the world of MIME types and how they play a crucial role in RESTful services. MIME stands for Multipurpose Internet Mail Extensions, and it's absolutely essential for HTTP requests and responses in RESTful services. Think of MIME types as the universal language that lets servers and clients understand the format of the data being transferred. In the context of REST services, specifying the correct MIME type is vital. It ensures that the client knows how to process the data it receives from the server. For example, when a client makes a request to a RESTful API, it needs to know if the response data is JSON, XML, plaintext, or something else entirely. Let's break down some of the most common MIME types you'll encounter in RESTful services. Text/plain, used for plain text files. Text/HTML, used for HTML documents. Application/JSON, used for JSON formatted data. Application/XML, used for XML formatted data. Application/XWWW form URL encoded, used for form data encoded in key value pairs. Multipart/form data, used for form data that includes files. Let's talk about HTTP status codes. HTTP status codes are essential for understanding the outcome of HTTP requests. They are standard responses given by web servers on the internet, providing valuable feedback about whether a specific HTTP request has been successfully completed or if there was an issue. These status codes are grouped into 5 different categories, each representing a different type of response. 1XX. Informational. These codes indicate that the request has been received and the process is continuing. For example, 100 continue means the server has received the request headers, and the client should proceed to send the request body. You'll rarely see these in everyday development, but knowing they exist is still valuable. 2XX. Success. These codes signify that the request was successfully received, understood, and accepted. For example, 200 OK means the request was successful and the server returned the requested data, and 201 created means the request was successful, and a new resource was created as a result. 204 no content means the request was successful, but there is no content to send back. 3XX. Redirection. These codes indicate that further action needs to be taken by the client to complete the request. For example, 301 moved permanently means the requested resource has been permanently moved to a new URL, and 302 found means the resource is temporarily located at a different URL. 4XX. Client error. These codes indicate that the request contains bad syntax or cannot be fulfilled. For instance, 404 not found means the server could not find the requested resource, and 400 bad request indicates that the server could not understand the request due to invalid syntax, and 401 unauthorized means the client must authenticate itself to get the requested response, and 403 forbidden. The client does not have access rights to the content. 5xx. Server error. These codes signify that the server failed to fulfill a valid request. For example, 500 internal server error means the server encountered an unexpected condition that prevented it from fulfilling the request, and 503 service unavailable means the server is currently unable to handle the request due to temporary overload or maintenance. These codes help in diagnosing issues on the server side. For example, if a Spring Boot application encounters an unhandled exception, it might return a 500 internal server error. In Spring Boot, you can also customize status codes. This is useful for creating more specific responses for your API. Now let's talk about how the client and server communicate in a REST API. In a REST API, the client sends an HTTP request over HTTP to the server, and the server responds back with an HTTP response to the client. An HTTP request and HTTP response consist of several components. Let's break down each one. An HTTP request consists of three components: the request line, headers, and body. Let's first discuss the request line. The request line contains three parts: HTTP method, URL, and HTTP version. HTTP method. This indicates the action to be performed, such as get, post, put, or delete. Each method corresponds to a specific operation. URL. This specifies the resource being requested. It typically includes the path to the resource and may include query parameters. HTTP version. This indicates the version of the HTTP protocol being used. The most common versions are HTTP/1.1 and HTTP/2. The next component of an HTTP request is the headers. Headers provide additional information about the request. They are key value pairs sent in the request to provide metadata about the request or the client. Some common headers include: content type, indicates the media type of the resource. Authorization, contains the credentials to authenticate a user agent with a server. Accept, indicates the media types that the client can understand. User agent, contains information about the user agent originating the request. Host, specifies the domain name of the server and the TCP port number on which the server is listening. Headers help the server understand how to process the request and provide context about the request. The final component of an HTTP request is the body. Body contains the data being sent to the server. It is used with HTTP methods like post, put, and patch, where data needs to be sent to the server to create or update a resource. The body can contain different types of data, depending on the content type header. The body is essential for sending complex data structures to the server, allowing for the creation and updating of resources. Next, let's look at the HTTP response. An HTTP response also consists of several components: status line, headers, and body. Let's take a look at each one in detail. Status line. The status line is the first line of the HTTP response, and it contains three parts: HTTP version, status code, and status message. HTTP version indicates the version of the HTTP protocol being used. Status code, a 3-digit number that indicates the result of the HTTP request. Status message, a brief, human-readable message that accompanies the status code. The next component of an HTTP response is the headers. HTTP response headers provide additional information about the response. They are key value pairs that convey metadata about the response. Some common headers include: content type, indicates the media type of the response. Content length, indicates the size of the response body in bytes. Date, the date and time at which the response was generated. Server, contains information about the software used by the origin server to handle the request. Set cookie, used to send cookies from the server to the client. The final component of an HTTP response is the body. The body of the HTTP response contains the actual data being sent back to the client. The content of the body depends on the nature of the request and the content type specified in the headers. For example, if the content type header is application/JSON, The body will contain JSON data. These predefined components help standardize communication between clients and servers, making REST APIs efficient and scalable. In summary, we explored the key aspects of REST APIs, including how HTTP methods correspond to CRUD operations, the role of MIME types in data formatting, the importance of HTTP status codes for understanding request outcomes, and the main components of an HTTP request. These foundational concepts are essential for working with REST APIs and building robust web applications. Thank you for watching. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and click the notification bell to stay updated. See you in the next video.